Polar coordinates. To plot any point in polar coordinate, you need r to represent the number of circles and theta to represent the angle. Plot the following point. P2 and the angle is 45. 2 indicates two circles and the angle 45 is a positive one, thus I will go counterclockwise and that's it. Another point Q, 3 circles and the angle is a positive one, counterclockwise, you convert it to degree and just you graph it as you can see in front of you. Now you have M, which consists of -4 and 60 degrees. First of all, because R negative, you will pretend it's positive and you will graph it as it is for the point 460. Then you will extend a straight line to the other side and you plot the point -460. Now to graph the following point, we have two circles and the angle is negative. First of all, because you will start graphing two circles. Now the angle is negative, thus you will graph it in a clockwise. The angle is -270 degrees and you remind yourself each quadrant consists of 90 degrees. Thus you go in a way that you will count up to -270, just follow the steps. Now the following point we have R is negative and the angle is negative. The first step, you will pretend that you are graphing a positive R and negative angle. Thus you will graph 3 circles and -4, it means you will go clockwise. Now because R is negative, you will extend a straight line to the other side and that's it. Plot the following points, then compare the answers with mine. The all polar coordinates for any point. For the point P, R, and theta, it has different polar coordinates. The first one is P, R, and theta. Now, the second one, it's P, R, and theta plus 360, a coterminal. Then theta minus 360. The fourth one will be P with -R, theta plus 180, and the last one will be P with -R and theta minus 180. Take the following example. Give all possible polar coordinates for the point P3 150. First of all, the first point is the one that given in the exam. Now the second one, you will start, P, R, theta plus 360, and you apply the calculations. The third one, P, R, theta minus 360. The fourth one, P, -R, theta plus 180. And the last one, P, -R, theta minus 180. Don't forget to apply the calculations as you can see in front of you. Try the following question, then compare the answer. Now to convert a polar point r theta to a rectangular coordinate xy, you have to use x equal r cosine theta, y equal r sine theta. In this example, r equal 4 and theta equal 3 pi over 6, which is 90 degrees. All what you have to say, x equal r cosine theta, thus 4 cosine 90, and y equal r sine theta, which is 4 sine 90, and the point after that will be 0, 4 in the rectangular form. Now stop your screen, solve this question, then compare your answer with mine. When you convert from rectangular to polar, take into consideration the sign of x. If x is positive, then theta equal tan inverse y over x. If x is negative, you have to add 180 to theta. Take the following example. Convert the point 2, -4 to a polar coordinates. We start first of all by finding the value of r. which is x squared plus y squared, and it will be radical 20. Then we will check the sign of x, and it's 2 positive. Thus theta is tan inverse y over x, and then use the calculator and find theta. Convert the following point to a polar coordinates. First of all, we find r, which is square root of negative 3 square plus 6 square, and we will find the value. Then we check the sign of x equal negative 3. In this case, it is negative, thus we have to add 180 to theta. Thus we will say theta equal tan inverse y over x plus 180. Then we use the calculator to find the rest of the answer. Converting from rectangular equations to polar equations. To do so, you will use the following facts. X equal r cosine theta, y equal r sine theta, tan theta is y divided by x, and r square equal x square plus y square. Converting and identifying the graph of below equation. The rectangular form is x plus 2 square plus y square equal 4. This is a circle with center negative 2, 0, and radius equal 2. Now we recall the previous facts, and whenever we will see x, we will replace it with r cosine theta, as you will see in front of you. So I need to mention that whenever you see y, you will replace it by r sine theta. Now we complete simplifying the shape, as you can see in front of you. We try to put similar terms, or maybe they look somehow not far away beside each other. Like I can see that, okay, I will get rid of 4, as you can see in front of you. Then I can see that I have r square cosine square theta and r square sine square theta. Thus I'd love to put them beside each other, because I'm gonna use later a certain trigonometric identity. Now I'm shifting 4r cosine theta into the other part, and I will end up having r square cosine square theta plus r square sine square theta equal negative 4r cosine theta. Now in both, at the left side, I can see I have r square as a common factor, thus I will take it outside. And inside the big bracket, I will have cosine square theta plus sine square theta, which is 1. Thus I will end up having r square equal negative 4r cosine theta. I will divide both sides by r, and I will end up having the answer r equal negative 4 cosine theta. Again, another example, you've been given the shape 4xy equal 8. We will simplify it into the form y equal 8 divided by 4x, and it's a reciprocal function, but keep in mind reciprocal function is another name for the hyperbola. Thus we recall that x equal r cosine theta, y equal r theta. We substitute them, as you can see, in the original equation. We will simplify, as you can see in front of you. I want you to follow the steps of solution. We will use at a certain point one of the trigonometric identities, which says that 2 sine theta cosine theta is basically sine 2 theta. Just please follow the steps as illustrated in front of you. Converting polar equations to rectangular equations. Convert theta equal pi over 4 or theta equal 45 degrees. Now take tan both sides. Tan theta will equal tan 45, which is 1. Thus tan theta equal 1. but tan theta is basically is y over x. Thus we will say y over x equal 1. We do cross product, we simplify, then we will discover that it is y equal x is the answer and it's a line. Another example, convert r equal 4 to rectangular form. We square both sides, thus we end up r square equals 16, and we recall that r square is basically x square plus y square. Thus we have x square plus y square equals 16. That was the end of the lesson. Thank you for watching.